Hi Math 111. In this video we're going to start our work in Chapter 2. We're going to talk about Section 2.1, and in this section we're going to be talking about some special kind of relationships. Okay, and we're going to talk about some special kind of relationships between collections of things, right? So just a little bit of a recall here for a second. Remember that I can use the word set here. If I use the word set, then I'm referring to a collection of objects, right? In this case, it's going to be a collection of numbers, okay? So when I use that word, it's a collection of numbers. Okay, so when I use the word set, I'm meaning a collection of numbers. Okay, so what we can do is think about how two sets are actually related to each other, right? Two collections of numbers, right? So I could, for example, draw something like this, right? And maybe you've seen something like this before, where I could say I have some numbers here, and maybe some different numbers here, 5, 9, and 7, or something like that, right? And these are each a set of numbers, right? So this is a set here, and this is a set here, right? They're each a collection of numbers, right? This is a collection of numbers, this is a collection of numbers. Okay, well, we can say that these two sets are actually related to each other, okay? They have a relation or something maybe between the two of them, right? And maybe the relation says that, 1 is related to 5, and 2 is related to 7, and 3 is related to 9, right? For some reason, I don't know why, maybe. Okay, and when we do this sort of a thing here, this is what we're doing called a relation, right? This is a correspondence between two sets, right? And that's over here on our definitions over here. Okay, so this is definition. A relation is a correspondence between two sets. Okay, and we say that these numbers here that we have inside of these sets, those are elements of the set, right? So 1, 2, and 3, those are elements of this first set. 5, 9, and 7 are elements of the second set. And we say that there's like a relation between these two sets, right? Somehow these two sets are related to each other. They correspond to each other, right? The elements of one correspond to an element in another, right? 1 corresponds to 5, 2 corresponds to 7, and 3 corresponds to 9. Okay? So when we have this kind of a relation here, we say that the elements correspond to each other or that they depend upon each other. And this is just one way that I've chosen to show you a relation here. This is what's called a map, right? So what I've drawn here, this is called a map. Okay, and this map shows us the relation here between the two sets by using these arrows, right? The arrows show that 1 corresponds to 5, 2 corresponds to 7, and 3 corresponds to 9, right? And so the direction of the arrow is kind of important because we want to say that 1 relates to 5 or gives 5, right? 2 gives 7 and 3 gives 9 for some sort of a reason, right? So this is called a map, or sometimes also called a mapping. Right? Either of those two words would be okay. What we do want to do when we use this word map or mapping is somehow say this set is different from this set, right? These elements in this set 1, 2, and 3 are different from the ones over here 5, 9, and 7. Okay, so what we do when we use this kind of map or mapping kind of picture is we call the things over here on the left, the things that we start with, things at the end, the beginning part of the arrowhead right here, or the arrow at the back, we call these inputs. Okay, the things over here in the left bubble, okay, the things we start with. And the things over here in the right bubble, the things that we end with, 1 corresponds to 5, right, the corresponding to stuff, those are called outputs. Okay, and again, those are words just that we have so that we can sort of make a distinction between this collection of numbers over here and this collection of numbers over here. Okay, so this is just one way for us to show a mapping or a relation, right? There is another way to show a relation. Another way is an equation. Okay. An equation is useful to show a relation because we can use an equation to show how two numbers are related to each other. For example, if we go back to our picture here for a second, right? What if I were to say, call this first set over here, the set of inputs, let's say that those are, let's call them values for x, maybe, perhaps, right? Then maybe I could say that these outputs here, this set, I could call them values for, oh, I don't know, y, right? If I have this kind of a relation here, then these values of x are related to these values of y, right? Okay, so that's that's a way we can, again, another way we can like label the collections of numbers here, right? But if I now go to this idea where I have an equation, then another way to show a relation would be something like this. Maybe I have an equation maybe like this: y equals x plus 3, right? This is an equation, and it does in fact relate one collection of numbers to another. For example, if I were to say try to draw a mapping showing this equation, showing this relation here, right, if I had my little circles here, and let's say this was x's and this was my y's, right? Okay, so this is set x and this is set y here, collections of numbers. I don't have any numbers in here yet, right? So let's just see how this would work. What if I did have the numbers, what about 0, 1, and 4? Right? So using this equation and to show the relation here between these two sets here, using this equation, if I say that x is 0, then y has to go to what? Under the equation, if x is 0, I put a 0 right there where x is. If x is 0, then that means that y has to be what? Y is defined to be, you take x and you add 3. So that means y would have to be 3. If x is 1, well, if x is 1, then y has to be 1 plus 3, which is 4. And that would be what 1 corresponds to. If x is 4 here, y has to be 4 plus 3, which is 7. So 4 corresponds to 7. Okay, so this is a relation, right? This is the mapping right here in the bottom, right? Okay, that's again another way to show a relation. But this equation here has more than just these values here, right? We could have used any value of x we wanted here, and there would be a corresponding value of y, right? There would be a value of y to draw the arrow to over here in this bubble. I can't draw bubbles big enough to use all the values of x and get all the values of y. That's why it's not reasonable sometimes to use a mapping to show a relation. That's why an equation like this can be really useful here, because this equation allows us to relate lots of numbers to each other, right? Lots of values of x to other different values of y here, okay? And I don't have to draw a big mapping with a million arrows or infinitely many arrows or something, right? Okay, this is a lot more efficient a way to describe an equation, right? The values of x are related to the values of y, and they're related by saying you start with whatever your x is and you add 3 and you get your value for y. Okay, so that's another way to describe a relation or a correspondence between two sets. Let's see, a different way is with a graph. Because of course we know that the values of x and y, like in this equation right here, are related, but you can have a visual representation of this equation, right? There is a visual relationship that we can actually show. And for our example right there, if I were to take that example and graph it, right? I know its y-intercept is 3 and its slope is 1, so I would just draw a line like this. Oops, pretend that that goes through 3. There we go. Okay, so a graph right here, this could show us, again, the relationship between the values of x and the values of y. Again, because if you think back to this like mapping idea here, when you take a value of x, say like 4, you know, if I were to take 4, it would produce a corresponding value of y, right? Here's, if x is 4 here, I plug that into the equation, and I get out a corresponding value of y, which is 7, right? Okay, so there is a relationship again, and the relation is between the values of x and the values of y here, right? Okay, so we have, let's see, so far we have a mapping, we have an equation, we have a graph. What else? Well, let's see, a table. We could do a table because, of course, instead of using this mapping idea here, we could put all of our information in a nice organized table. Okay, so what we could do is instead make a table of values of x and corresponding values of y. And for ours that we did before, remember we've had different examples, but let's take the equation that we had before. I think we did 0, 1, and 3, right? Let's go back a page and make sure that's right. Oh, we had 0, 1, and 4, right? So let's do that one again, 0, 1, and 4. So let's erase that 3, and we'll put a 4. Okay, and we notice that from our equation here, remember our equation was y equals x plus 3, right? Remember, we found that our corresponding values of y, 0 corresponds to 3, 1 corresponds to 4, and 4 corresponds to 7, right? Remember, we had our mapping with the arrows, we had our graph, we had our equation. There's a table, right? So there's another way for us to represent a relation here with a table. Again, is this the most efficient way to do this? Not necessarily, because in order to really say all the relations, all the correspondence between the values of x and y, I'd have to list like infinitely many things here, right? Because I could plug in whatever I want for x here and it'll have a corresponding value of y. Okay, so this could be an infinitely long table. So that's not really efficient. Again, the equation is sort of the best way to go about this. The last way to show a relation or show a correspondence between two sets of numbers is as a set of ordered pairs. So we can write the last one, set of ordered pairs. Because we know that if there's a value of x and y that are related to each other, we can write them as an ordered pair, right? This is just like when we had our graph. It's a collection of all the ordered pairs, right, that work for this equation here. So we could just make a set, a collection of all those ordered pairs that do in fact work for the equation. And for ours, that would look something like this. We use squiggly brackets like this to write set. Okay, we write a big squiggly bracket like this, right? Big squiggly bracket means a collection or set of, and you write all the stuff in the set on the inside of these squiggly brackets. So now we just write all the ordered pairs. 0 corresponds to 3. That's right there, 0 and 3. Separate the items with commas. 1 corresponds to 4. And 4 corresponds to 7. Okay, so this is a set, squiggly bars, right, of ordered pairs. And the items, the elements in the set are ordered pairs, right? We've got 1, 2, 3 of them, 3 ordered pairs. Okay. So this is an example of a relation, right? There's lots of examples of relations. So let's take a look at a different example. So I'm going to, let's see, let's look at, if you look at your textbook, you can look at number 15 in section 2.1. So 2.1, number 15. Okay. And what they have is an example of a relation here. This one is a relation not between numbers, but between names of people, right? So if we had a big bubble here, right, we could write some names, right? So we got Elvis, we've got Colleen, it looks like Kaylee, I think that's Kaylee, and Marissa. Okay, and then, so that's our first collection, our first set, right? It's a set of names, right? And then on the other side, we have some other information. It looks like some dates. Here, January 8th, March 15th, and September 17th. Okay, and it looks like the relation says that Elvis goes to January 8th, Colleen goes to January 8th, Kaylee goes to March 15th, and Marissa goes to September 17th. Okay, so what could this relation have represented? I mean, there's lots of different possibilities. We're not even actually told, right? But for example, this relation could show people and their birthdays, right? So this could be a relation between names and birthdays, right? So this would say Elvis corresponds to January 8th, so Elvis's birthday is January 8th. Colleen is also January 8th. Kaylee is March 15th, and Marissa is September 7th for birthdays. It could be hiring date, maybe the date that they were hired to work for their employer. Anything of that nature where there's some sort of date this could be the representation of that relationship, right? Of that relation. Okay. So what's interesting to consider, though, is a special kind of a relation, right? And there are certain kinds of relations that we are going to consider in Math 111, special ones. And these kinds of relations are called functions, right? So these are special relations. Okay, in our next video, we're going to explore just exactly what we mean by a function. Okay, so on to video 2.